I'm Jamie Cohen Cole. Welcome to the course. In this class, we'll be doing three things. We'll be examining the history of the major scientific developments of the long 20th century, roughly 1870 to the present. We'll be focusing on America and its society. But the sciences and technologies that we look at are not local, but global phenomena. Biology, physics, and the atomic bomb, all of these things are things that happen not only in America, but also connected America to the rest of the world. And yet, most of our attention will also be focused not on science itself, nor on society itself, but on the connections between the two. So we'll be asking, how did science change society, and also how does society change science? In the process, we'll be rethinking easy ideas and popular definitions of what counts as politics. Politics here means not just parties and elections, but also things like race and gender. In terms of politics, we'll be asking things like, what is the ethos, the cultural and political values that are held by a people? In terms of science, we'll be asking, are there specific values and ethos that make science function? Things like honesty, integrity, organized skepticism, and disinterestedness. Does this ethos and these scientific values naturally go together with democracy? So, does science happen better in democracies? And if so, why? And if this democracy promotes science, is the reverse true? In terms of politics, to what extent is science naturally a part of modern society? Does modernity mean not only the kinds of technologies we use, but also how we organize our relations with one another, and even how we organize our political system? Here the issue is how we manage experts. Science is too complicated for everybody to understand. And if so, what does this mean for our political culture? How much trust do we put into our experts? Do we allow them to plan our societies? And if so, how do we choose our experts? If I'm not a scientific expert, how do I know which scientific experts to trust and when? What do I trust them with, and what do I not trust them with? Do I trust them to build a bomb? Do I trust them when to use it? These are simultaneously scientific questions and political ones at the same time. For instance, consider the case of J. Robert Oppenheimer, who was the father of the atomic bomb and director of the Manhattan Project during World War II. After the war, he advised the United States on atomic and nuclear policy. In this period, he opposed the development of hydrogen bombs because he was not convinced they could be built, and he thought they would make for bad weapons if they could be built. To some people, these views of his meant that Oppenheimer was untrustworthy as a scientific advisor, both because he didn't know how things would work and he had bad politics. We will be considering Oppenheimer's case and others, and in the process examining how the decision to put our trust in experts involves simultaneously political decisions, judgments about their knowledge, and judgments about their character. Yet the modernity of science is not only about experts, it's also about how we live our lives day to day. It involves the distribution of new technologies, such as electricity. In the turn to new technologies, we get new social forms and new political issues. So electricity, it provides benefits. It's a marker of modernity, and its lack is now a marker of backwardness. Its development implies modernization and new standards of living. It requires investment from a strong central and modern government to make it available to citizens. But to the extent that government brings electricity to the people, the government itself changes in the process. In this instance, as with others we discussed in this class, making a commitment to modernity also means a commitment to specific forms of government and to the kinds of relationships citizens would have to experts, to political leaders, and to each other. These commitments, as much as ethos, are a matter of values that are at once political and scientific. What kind of person is the scientist supposed to be? What is the scientist's social identity? What personality does he or she have? What are the qualities of a scientist? One answer to this is to look at the scientific ethos. Consider the values that scientists are supposed to uphold. Robert Burton argues that such values are characterized by honesty, integrity, organized skepticism, and disinterestedness, and that these are a marker and promoter of democracy. These were popular views at mid-century, but it has not always been the case. Indeed, Science is an index of political values, and therefore the history of scientific personae give us the history of politics. So what is personae? Well, compare waiters. Waiters are a new thing, a new social role. This social role had to be created when restaurants were invented. Waiters have a job to play, and so too do customers, and they both have personae. So think of scientists having the same kind of thing. They have a social role. It's a strange social role, though, because scientists are not often seen as social at all. In fact, they're seen as antisocial. If science is said to be independent of particular traits, we still assume that some kinds of people are more likely to be non-persons in this way. So what kind of person displays these qualities? Well, there's the ascetic, because it implies that the scientist is removing himself or herself as much as possible from corrupting influences. That is, if science is supposed to be non-social and placeless and timeless, then the scientist should be non-social too. Hermits were supposed to be able to perceive higher truths, because they rid themselves as much as possible of the influences of corrupt, changing human worlds. Scientists do the same. Another type of this person is a loner rebel. This goes beyond mere physical isolation and includes the trickster, such as a computer hacker. Another type is a technical specialist, an expert. This is a person who's not a philosopher or a generalist, but a specialist, somebody who's mechanically adept. The way to think about personae is to consider a few of the people who specialize in the study of nature. I'll show a few of them in sequence to you and then discuss their personae in more detail. These were not all scientists. Before the mid-19th century, they called themselves natural philosophers. First, Ptolemy. He was a court sage, a mathematical astronomer, the man who developed a mathematical model of a geocentric cosmos that was used for close to 1,500 years for the making of calendars and describing the positions of the planets day to day and year to year. His model was eventually replaced in the 16th and 17th centuries. His job was casting horoscopes for kings. Second, Robert Boyle. He was an English natural philosopher. During the 17th century, he helped to develop the molecular model of gases and developed the first instruments for the study of low-pressure phenomena. He argued that space with no air was a vacuum. He built a scientific society where people could come together and observe experiments and write up their observations. He was a gentleman, and that made him trustworthy. He was rich, strongly religious, and moral. Third, Isaac Newton. He was a late 17th century mathematical physicist. He came up with a new cosmology and a new physics, and he was an inventor of the calculus, mathematics. The public image of him was as a lone genius, a hermit, and maybe even a saint. He was a loner, an ascetic, and absent-minded, said only to have laughed twice in his whole life. He was also seen as a vengeful man. Next, we have Charles Darwin. He was a mid-19th century biologist. He co-discovered natural selection with Alfred Russel Wallace. Darwin was a country gentleman and then later in life a sage. He was independently wealthy, but not so much as Robert Boyle. Next, we have Huxley, who is known as Darwin's bulldog. He was in the first generation of paid professional scientists. The 20th century gives us new images of scientists. There were mad scientists we see in fiction and in the new technology of movies. For instance, in the figure of Rotwang, the evil genius and inventor of robots in Fritz Lang's silent movie Metropolis. Then there's the ethereal, head-in-the-clouds scientist we see as Albert Einstein, who was a sage and a dispenser of political advice. Others, such as Oppenheimer, were more stylish than Einstein. And then there's the scientist as joker and trickster, Robert Feynman. And then there's the scientist who's somebody who is seen as having pure mind, somebody whose body is not important at all. Stephen Hawking is an emblematic case of this. And then scientist is somebody who defies social conventions, including in the case of the Nobel Prize-winning Kary Mullis, who defended astrology. These varied personae tell us about the values of the times they came from. It tells us that only gentlemen were to be trusted to see and tell the truth in the 17th century. And the 20th century values a different kind of person, one who is an expert, a government administrator, and or a maverick. In different ways, all of these people are supposed to stand outside of regular social conventions. But, as we see, like waiters, scientists also play act. They carry out conventions of seeming, but only seeming to be above or beyond social rules and the social roles they play.